Hello, and welcome to Part 3 of the Course Overview module. In this part of the module, we're going to build on the previous two parts. Part 1 explored the motivations for and challenges of concurrent and network software. Part 2 described how patterns and frameworks helped address the challenges of concurrent network software. And in Part 3, we're first going to outline some of the course prerequisites, and then we're going to present an overview of the first 3 sections of the course syllabus. When I teach courses on patterns and frameworks at Vanderbilt University, I can rely on the students having taken the prerequisites. One of the challenges of teaching a digital learning course like this one is I don't really know what you know. Here are some of the things I'd like you to know in order to be able to get the most out of the class. Probably the most important thing for you to have as background coming into this course is some knowledge of object-oriented programming and object-oriented programming languages. You need to know what classes are, inheritance, dynamic binding, parameterized types, the kinds of things you'd find in popular languages like Java, C++, C#, Python, and so on. You can make it through some of the sections of the course, but you'll really struggle with the last section if you don't have some grounding in object-oriented programming. So if you're a little rusty in this area or you don't have a background, I highly recommend that you go out and avail yourself of the resources available on the internet. Things like tutorials on YouTube, other things you can get through the web that will give you an overview of object-oriented programming. It's also useful if you have some knowledge of object-oriented design. Things like encapsulation, abstraction, polymorphism, extensibility, all the various design techniques that can be used to hide information that's likely to change from clients so that when the inevitable evolution takes place, you don't have a lot of rework to do to catch up. Something else that's important is to have knowledge of the unified modeling language. The unified modeling language makes it possible to describe in a fairly rigorous but not overly formal way various structures and interactions of software, both object-oriented, component-oriented, and regular function-oriented software. You don't have to be an expert in UML in order to be able to make sense of this course, but I recommend you take a look at this link and other resources that you may be able to find through books or online to learn enough to be able to understand what the diagrams mean, what the associations are, what the roles and responsibilities are there for. Something else that would be very helpful to know would be to have some kind of systems programming knowledge. Things like event demultiplexing, multi-threading, multi-processing, synchronization, local and remote inter-process communication, or IPC. These are the kinds of things we'll need to be able to cover, so when we talk about the patterns and frameworks, you'll understand what the basic building blocks are that provide the concurrent and network capabilities under the hood. And of course, it would also be great if you had some background in networking concepts, things like client-server architectures, peer-to-peer architectures, protocols like TCP/IP, the concept of layering like you might find in the ISO OSI reference model, and so on. Once again, if you don't have a lot of background in these areas, or it's been a while since you've covered them in courses or other work, don't worry. We will go through and summarize object-oriented design, systems programming, and networking concepts through other parts of the course. Let's talk now about how the course is organized into sections. There are 3 sections in the course. Each section is something like a volume in a multi-volume book series. Each section is composed of modules. A module is something like a chapter in a book. Each module is composed of parts. Each part's like a part of a chapter or sections in a chapter. You'll find that each part is roughly 15 to 20 minutes long or so, and around every 5 minutes, a quiz will pop up so you can check to see whether you're keeping up and mastering the material that we're covering. We're also going to have several programming assignments that can be written in either C++ or Java. If you're trying to take the course to get a so-called statement of accomplishment, then you're required to do the quizzes and the assignments. If you're just taking the course to learn the material and expand your knowledge, you can ignore the quizzes and assignments. So let's talk about each of the sections. Section 1 provides an introduction to concurrent and network software. We'll talk about communication-related issues. We'll talk about concurrency and synchronization. We'll talk about the ways of partitioning systems up into various services and how you configure them, and so on. We'll also be discussing the different layers of concurrent and network software, some design issues to consider. And then we'll spend a little bit of time providing that background I discussed before so that you will have an understanding of some of the key operating systems programming mechanisms, as well as some of the mechanisms that you'll find if you're using Android, because Android will figure very heavily in some parts of the course as well. This part of the course, this section, focuses primarily on concepts. There's very little code. There's really not much even discussion of patterns at this point. We're really talking about the basic building blocks you'll need to make sense of the other material that we cover. Section 2 is where we start to dive deeper into patterns and frameworks. Of course, we'll provide an overview of patterns and frameworks in general, but our primary emphasis will be on patterns and frameworks for concurrent and network software, since that's the focus of the course. We'll talk about pattern and framework concepts. We'll give a number of examples of patterns and frameworks. We'll talk about different relationships that patterns can have with each other. We'll also give an honest assessment of the pros and cons of patterns and frameworks. When should you use them? When should you be careful not to use them? What are some of the alternatives to use if they don't work for what you're trying to do? And of course, we'll also provide a summary of some reference material that goes above and beyond what we'll have time to cover in these videos. This part of the course will largely focus on design. That's why it's so important to have good knowledge of the unified modeling language. There's some Java, C++, and C code in these examples, but you don't have to be an expert at those languages to make sense out of this section of the course. The third and final section of the course is where we're really going to delve deeply into the implementation of the patterns, how we apply them, how we build systems using patterns, using groups of patterns called pattern sequences or pattern languages. We'll be talking about a number of different examples and a number of different ways of applying patterns and frameworks for different kinds of things. We'll talk about patterns and frameworks for service access and configuration, event handling, concurrency, synchronization, inter-process communication, and so on. Many of these patterns are going to come from the Pattern-Oriented Software Architecture Volume 2 book, which provides patterns for concurrent and distributed objects. That's so-called POSA 2. There's a whole series of books called the POSA series. POSA 2 will be where many of the patterns in Section 3 come from. We'll also spend a little time discussing some of the patterns from another classic work of pattern literature called the Gang of Four book, or the GOF book. The book's full title is Design Patterns, Elements of Reusable Object-Oriented Software, and it's one of the classic works in the field. There's going to be lots and lots of Java and C++ code in these parts. So this is where you're really going to have a good solid grounding in those languages to make sense out of the examples we go through. In order to be able to make the examples as concrete and as interesting and relevant as possible, I've chosen a running example to illustrate the patterns and frameworks at work. We'll be using an example from the domain of high-performance web servers, a framework-based web server called JAWS, which is developed using many patterns and framework concepts and capabilities. We'll be illustrating this web server using both ACE and C++, as well as Android and Java, to give you a broad view of how patterns can be applied from a number of different perspectives with a number of different technologies and languages. Throughout the course, we'll also be providing other examples beyond web servers to illustrate key points. We'll show some examples of object request brokers, avionics control systems, and of course, we'll also be spending a lot of time talking about examples of mobile application development using the Android operating platform. There's a lot of material we're going to cover in this course, and I cannot expect you to have mastered all of it before we start. So here are some tips that you might want to think about and consider to get the most out of these lectures. The first thing to do is watch the videos multiple times. If this was a face-to-face course, then it might be the case that if you were sick and missed class or had to travel, or you just zoned out at some point during the lecture, whatever I may have said would have evaporated into the midst of time, and you'd have no way of being able to go back and reconstruct or reconstitute what we had discussed. In contrast, with digital learning in the video series, you can go back and rewatch material multiple times, watch it at different speeds, until you feel that you have attained deep mastery of what it is we're trying to convey. Something else you should do is take some time and follow the various links I provide at the bottom of many of the slides. These links are often to resources, papers, documentation, source code, and so on that I've written with my colleagues, or some other people that are experts in the field have written to describe various aspects of concurrency and network software with respect to patterns and frameworks. All these links are freely available, and I encourage you to take some time to sift through them and figure out what you could avail yourself of in order to get the most out of that part of the course. Reading the freely available material is great, but sometimes you just can't get better information than to go out and take a look at the various books that are available on these topics. There's books available on many aspects of patterns for many different domains, different aspects of frameworks. We have a recommended reading list that I've put on the course website, and I encourage you, if you have the opportunity, to get those books and to spend time sifting through them to figure out what's most important to get what you need out of the material that we're covering in the video lectures. While it's nice to be able to sit in the comfort of your dorm room, your office, your home, and watch these videos, there's some times when you just can't beat the face-to-face experience. Getting together with real people, talking about interests of common mutual concern, working through some of the examples that we discuss, getting some tips and mentorship from other people who may be at different levels of advancement to give you a better perspective on what we're covering. So I recommend you take a look and see if you can find so-called meetup groups in your area where you can get together at a coffee shop or some other location to discuss this material, to get it and understand it more deeply. The Coursera organization has meetup group organizations and meetup group websites that you can take a look at to find who around your area might be able to meet with you. And I encourage you to take advantage of that if it's something that you can do. Even if you can't get together person to person, face to face, you might be able to do the next best thing, which is to avail yourself of some of the course online discussion forum material so you can interact with other students, post questions, give answers, clarify points that seem a little confusing, learn who else is out there who may be wrestling with similar challenges you are. And myself and the TAs will regularly be on the online discussion forum, so we'll help be able to provide you with tips and pointers to mentor you through this process as well. And finally, if you're really inspired to learn more about concurrent and network software and how to improve them through the use of patterns and frameworks, I encourage you to apply to Vanderbilt University. We teach a number of courses here in the CS program. I teach several courses on patterns and frameworks for general purpose computing, for concurrent and network systems, distributed systems, mobile systems, and so on. And a number of my colleagues also teach related courses that might be of interest to you if this is something you like to do. We don't just do teaching at Vanderbilt, however. We also have cutting-edge research on various topics related to patterns and frameworks applied to distributed real-time embedded systems, mobile application environments, cyber-physical systems, cloud computing, and so on. And so you might want to also take a look at this website to find out more information about the Institute for Software Integrated Systems where I work, where we do this research. And you may also want to apply to come and be involved with us there. So I certainly look forward to interacting with you virtually through the digital learning videos. And if I'm really lucky, I look forward to being able to see you face to face at some point in the future as well.